Good day, students. We're then discussing the three gas laws showing the relationship of volume, pressure, and temperature of gases. The volume-pressure relationship wherein they are inversely proportional to each other, described on Boyle's law. The pressure-temperature relationship wherein they are directly proportional to each other, described on Charles' law. And last, the pressure-temperature relationship of gases wherein they are directly proportional and is described on Kay-Lussac's law. Now, let's sum up the three gas laws on one great gas law called combined gas law. Here's an example of combined gas law. As the temperature increases on the boiling water, the pressure also increases while the volume do not change until the container cannot hold the pressure anymore and escape the container that decreases its pressure and makes the volume of the gas bigger as the temperature continuously increasing. Now, combined gas law shows that volume and pressure are inversely proportional to each other while they are both directly proportional to temperature. As their relationship is constant, if there is a change happens, their relationship is still the same. So this one is an equation to be used if one quantity between pressure, temperature, and volume is unknown on a given word problem. Now, let's use this equation on a word problem. So let's say we have a helium gas has a volume of 250 ml at 0 degrees Celsius at 1 atm or 1 atmosphere. What will be the final pressure if the volume is reduced to 100 ml at 45 degrees Celsius? First, let's get the given quantities on this word problem. So we have the 250 ml as our initial volume, 0 degrees Celsius as the initial temperature, and 1 atmosphere as our initial pressure. Now, after change, we have 100 ml as our final volume and 45 degrees Celsius as our final temperature. Now, always remember that on a gas, if there is a given amount for temperature, we always need to convert it into Kelvin. So on this word problem, we have a temperature on a Celsius scale. So first, we need to convert it into Kelvin scale. And to do that, you need to add 273.5 on the given degree Celsius. So for our initial temperature, which is 0 degrees Celsius, if we will add the 273.5 to make it a Kelvin scale, we will have 273.5 Kelvin. For the 45 degrees Celsius, just add 273.5 and we will have 318.5 Kelvin. So having the following givens, we need to then identify the unknown or the required quantity or the unknown quantity on this given word problem. And to do that, we need to use or to take a look on our equation and on our given. So on our given, we have initial volume, we have initial temperature, we also have initial pressure, we also have final volume, and last we have final temperature. So we have the following givens, and the one that is not given on this problem is the final pressure. So the unknown or the required quantity is the final pressure. So what will be the final pressure after the change on the helium gas? And to do that, we need to come up with an equation to get the final pressure. And to do that, always remember that we need to divide both sides of the equal to leave the unknown or required quantity alone on one side of the equal. So to do that, we need to divide both sides of the equal to the quantity beside the unknown one. So the unknown one is the final pressure, and the quantity beside it is the final volume and the initial temperature. So we need to divide both sides to final volume and initial temperature so that we can cancel out the final volume and initial temperature on one side of the equal, and we will leave the final pressure, which is the required quantity, on one side of the equal. So we have this equation wherein final pressure is equals to the product of initial volume, initial pressure, and final temperature over the product of final volume and initial temperature. So this one. Now, to solve this problem, we need to put the quantity on this equation. So we have the final pressure equals to the product of initial volume, initial pressure, and final temperature over the product of final volume and initial temperature. So first, get the product of these three, and below is this 2. So 250 multiplied by 1 multiplied by 318.5, and below we have 100 multiplied by 273.5, and we will have this one. So 200 ml multiplied by 1 atmosphere multiplied by 318.5 Kelvin, we will have 79,625 ml atmosphere Kelvin over 100 ml multiplied by 273.5, we will have 27,350 ml Kelvin. So all we have to do for this last one is to divide the 2. So 79,625 divided by 27,350, and we will have the answer of 2.91 atmosphere. Now we get the unit atmosphere because we need to cancel out the Kelvin and the ml to leave the atmosphere as a unit. Now, let's take a look what happens between volume, pressure, and temperature on this word problem. So, we have the volume. So, initial volume is 250 ml. After change, we have the final volume of 100 ml. So, as you can see, from 250 ml to 100 ml, the volume decreases. As for the pressure, from 1 atm, it changes to 2.91 atmosphere, so the pressure increases. For the temperature, we have an initial amount for the temperature, which is 273.5 Kelvin. After a change, it changed into 318.5 Kelvin. So as you can see, the temperature increases. So volume is directly inversely proportional to pressure. So if volume decreases, temperature increases. As for the temperature, as the temperature increases, the pressure also increases. Now let's have another example of word problem. So the volume of a gas at 27 degrees Celsius and 700 millimeter of mercury is at 600 ml. What is the volume of a gas at negative 20 degrees Celsius and 500 millimeter of mercury? So first, let's identify the givens. So we have first the 27 degrees Celsius, which is our initial temperature. We also have the 700 millimeter of mercury, which is our initial pressure. We also have the 600 ml, which is our initial volume, and negative 20 degrees Celsius, which is our final temperature. And last, the 500 millimeter mercury, which is our final pressure. Now, to identify the required one, we need to use this equation. So we have defined initial temperature, we also have initial pressure, and initial volume. We also have final temperature and final pressure. So among this equation, the one that is unknown or required is the final volume. Now for the equation, divide both sides to the quantities beside the required one or the unknown one. So on this problem, we have the final pressure and initial temperature. So we need to divide both sides to final pressure and initial temperature. To cancel out final pressure and initial temperature on one side of the equal, and left the final volume, which is the unknown or the required one. So we will have this equation. Final volume is equal to the product of initial volume, initial pressure, and final temperature over the product of final pressure and initial temperature. For the solution, just put the quantities. So we have 600 ml for our initial volume, 700 millimeter of mercury, which is our initial pressure. We have the 253.5 Kelvin, which is our final temperature. For the 500 millimeter mercury, that is our final pressure, and 300.5 Kelvin, which is our initial temperature. So get the product of these three and product of these two. So 600 multiplied by 700 multiplied by 253.5 Kelvin, we will have 106,470,000 millimeter of mercury Kelvin. And for the 500 millimeter mercury multiplied by 300.5 Kelvin, we will have 150,250 millimeter of mercury Kelvin. Then last, we need to divide the two for us to get the answer. So 106,470,000 millimeter of mercury millimeter of mercury Kelvin over 150,250 millimeter of mercury Kelvin. We will have the final volume as 708.62 ml. Now let's take a look what happens to the volume, pressure, and temperature in this word problem. So volume have an initial amount of 600 ml, changes into 708.62 ml. So as you can see, our volume increases. As for the pressure, from 700 millimeter of mercury, it changes into 500 millimeter of mercury. So our pressure decreases. For the temperature, from 300.5 Kelvin, it changes into 253.5 Kelvin. So our temperature also decreases. So volume is inversely proportional to pressure. So as the volume increases, pressure decreases. While pressure and temperature is directly as the pressure decreases, the temperature also decreases. That's it for the combined gas law. I hope you understand our discussion for today. Thank you.